Hello everyone, today is October 2022, so today's problem is sort array. So that's basically common question quiz about sorting an array with different method algorithms. So that's a sort array in ascending order and return. So So that's need you implement your own function to do the sorting and require big O and log n. So before that, I have implemented a quick sort for that one, and so far I just using the new one. I just learned a heap sort. Yeah, basically heap sort is trying to get they will organize the input array as a binary trees, and in sorting, during the sorting, they will do, try to find out the maximum tree, and if not meet maximum tree, maximum on root on top, they just swap the child tree and his root, and finally, and do the loop. I'm going to explain the heap tree right here. See if I could do that right. So, for example, so maybe that's the 7, 8, 6, 5, 4, 1, 2, 3. Okay, that's the tree. Based on the input right here, I could do the top will be the 7, left will be the 8, the right child will be the 6. Okay, and 8, root 8 has 2 child, 1, 2, and here 5 has the 3. Okay, here we go. So that will be searching from here. So they will check if that tree has no child, they just moving forward. Moving forward means have no child, they just move the pointer to here, so back to here. Since there's no child, we just moving, and keep moving until 5. Okay, when they do move to 5s, that will check 5s, the root his child will be 3. In the 3, that's already the bigger, so that's okay, let's keep moving. We're moving here, right here, 6. 6 has 2 child, he check both one child as less than his root, he do nothing. And moving to 8 has the 1, has 2 child, 5, 4, so it's the same thing to do nothing. And finally, they do the top root, they check 7. 7, they will check the 6, no. But for 8, since his left child is bigger, so they will swap. They just swap 7 and 8. So that will be the 8, 7. Okay, so far it's done. So that will do swap here 8 and 7 and 3, the bad root. So they just swap 3 and 8 right here. So that will be the 8. That will be the 3. Okay. In that case, they find the biggest 4 items right here. So they just, I mean, in logically, they just regenerate this new one here and do the search. They take this subtree as the new tree and do the algorithm again from there. So that means they got that one 3, 8, 6, 5, 4, 1, 2, 3. No, that's 7. Since they swap 7 and 8. That's a new one. 7. So the new tree will do like this. For the second loop, they just start from 2 and do that loop again until they finish the whole search. That will be basically the heap sort algorithm. I hope I present that algorithm clearly and you got that idea. Next step will be coding. Yes. Okay, similar things. And one thing we do, there are possible the duplicate items in the input array. So we maybe need to handle the comparison with equal condition or not. We do that in the coding. I reset default code. Yeah, here are the ones. Yeah, back to my favorite console and editor. Okay, same things. I'm do sort and an array by heap sort .c and paste the main function. So first one, let me see how many pointers we need. So we need to mark the start one, so we need P1 to mark the current one always. We need the search one to the P search. That's one pointer. And we could calculate every one child. So we don't need, we just do search. Okay, this is one to the end, P1 to the end. We call that a P end. This is one to the search. So we could calculate everyone's nodes. Everyone nodes will be, so that's 0 index. And so 0, 7 root will be 1, 2. Okay, that seems double I, index I, double size plus 1 and plus 2. Is that right? Let me check. So 3, 4, 5, 6, 7. Okay. For the 8 child, let me, this 7, that's 8, we connect 3. For the 8 child will be 8 is 1, so 1 is 2, no, 3 and 4. 3, 4, 5, 4, okay. For the 6, there will be the double 5 and 6. 5, 6. And for the number 5, his left child is 7. Okay, that's the one. So we got the child will be 2 left child and right child. Okay, that's the calculation for the binary tree search. Okay, that's the one. We just calculated. We got one pointer, second pointer for the search. Liquid swipe, and yeah, that's basically we just do. Yeah, we just do pointer. Actually, in that pointer, since that's zero index, we just need the index. We don't need a pointer. We just need the index of the array. That's it. Okay. Back to the coding. Let me see. So we need an integer. We just need integer search. So we got that index search and index. Let me use search and the end using the apprehension. So we just mark these two. We also need a search index as well. So the index search will be number size minus 2, since that's 0 index, and the index and will be number size minus 1. Okay, that's the one. Okay, then the for loop will be for we just need a void swap. So we need swap. So another thing is for loop, we just need I start with the indexes and until n once I greater than 0, even equal 0, we could still do that. I minus minus. Okay, so in the loop, we just check if I plus 1 greater, let me see, so I'm thinking if I need to do the search, let me do the I. So I will be if greater 1 plus 1 is greater than index and and numbers I is less than numbers 2I plus 1. Only in this case, we do swap. We do swap numbers I and numbers plus 1, his left child. Okay, in that case, we will check the right child. Since that less than and his 1 is 2, we do that one. Okay, that's left child. Else just minus I. Yep. Yep. While index search node end great than the 0, we do the search. Yep. Index and minus 1, okay? And we just need aligned. Let me see. So that's 1. So we just switch, and oh yeah, that's one more thing. After swap, we could do the optimization to swap again, but it's not necessary for this implementation. So okay, let me mark to do once swap if we need recursively check its subtree for max root status. Okay, that's the one. And after swap, we just swap numbers 0 and numbers index end. In that case, we don't do this. Okay, we don't need the search. We don't need the search as well here. Okay, let me check. Let me check the set case right here. Let me finish the coding, then I check the set case. After while, just return size equals numbers and return. Okay, set case. So when we search the end to I minus 1, I equals 0. I equals 0, that's, you check 0, all the stuff. Okay. Yeah, I think that's okay. Yeah, next step, I'm going to run that code in the Leetcode to see what's the running result. Okay, all this stuff right here. So I do see one more character inserted. I'm going to run it, see how it's going on. That looks good. Wrong answer. So let me see how many test cases I have passed. Only second failed. That's weird. Output 2315. It's done. It's done. How that happen? So in that case, the index will be the false 3, right? And nobody. How that end? 2315. That should be 4. That's 3, right? That's 3. And going to 3, 3 greater than 0. That's fine. We do there. We swap. And 3 minus 1 equals 2. Yeah. Right, that's cause that's 3. Two, three, one. Oh, 221. 21. Why that's 21? Index. Okay. Okay. Hold on. 332110. Okay. That's because I don't get return. You know why for that? Okay, that looks good. Actually, that looks good. Okay. So that means we only swap 1, 2, 3, 1, 5. And oh, that's okay. Let me see. That will be 2, 3, 1, 5. Okay. 2, 3, 1, 5. Okay, that would be the 2, 3, 1, 5. Okay. We search here. That's no need. We search here. No need. We search 3. We just 3 swap there. That will be the 5, 3. Right? So, okay. And we search here. We just got 2, 5. We just swap this one. We just swap 3 and 5. So the new one will be the 3, 2, 1, and a 5. Okay, that's fine. We search this one, we search this one, we swap that one. We search this one, search this one, we swap that one. Right. Why that doesn't swap? How that doesn't swap? I'm expecting swap. Five, 1. That's fine. And 1, 3. 1, 3. Why that's already 3? Okay, 3, 2. Hold on. 5, 1. Okay, 5, 1. Okay, that's 1. That's the 1. And that's the 3. For the second time, that's the... Okay, for the 3, 2, 1. 0, 3. Switch. They will switch. 3, 1. Okay, that will be the 1, 3. That's why that's 1, 3. File 1, switch file 1. Two, 3, 1, 5. Okay. First one will be 3, 5, 3, 5, 3, 5. Oh, that didn't switch 3, 5. That's wrong one. First one we will do 3, 5. Okay. Let me see. So some condition right here. Once this one less than that one, and the numbers we swap. So we will do, in that case, we will switch 3. Okay, that's, yeah, that's the first one. We didn't switch, that what happened. Okay, for the first one, for the second one, so that's loop 1, 2. Three, 2, 1. Okay, that's wrong. 3, 2, 1. That will be the 3, 3, 2, 1. 3, 2, 1. We expect happen right here, right? 2, 0, 1, 2. That's 1, 2. No. Yeah, 2. Okay, that's wrong. Oh, okay, wrong one. Sorry. Okay, I'm kind of tired, so I'm going to stop today, and I will keep doing that tomorrow. Thank you for watching. See you next time.